Alright, hello guys. So I kind of screwed up doing this, but like I tried to record this while I was typing everything in and making my notes. Then it kind of screwed up. So I guess I'm just gonna highlight what I did here. So first of all, I'm gonna change the color so you know what I'm doing. So first I wrote down all my givens based on the question. So the mass is 100 kilograms. My coefficient of friction was 0.7. I didn't know my time. My final velocity was 96 kilometers an hour. My initial velocity was 0. And then I converted my final velocity into meters per second, so it's easier to work with. So then I drew my free body diagram. So the trick with this question is that because it's a car, over here in this diagram here, because it's a car, it has tires, and the tires is in contact with the asphalt. So that's what coefficient of friction means, because you need friction between the tires and the asphalt in order for the car to move forward. And that was the confusing bit. So therefore, the friction force actually determines the maximum acceleration, maximum force that the car can accelerate itself. Because if the car applies any more force than that, then that would mean the tires won't have friction with the asphalt, meaning it will lose traction. If you guys have any questions with that tidbit, I can explain it more next class. So now I'm looking at my free body diagram here. And my free body diagram, you can see that we have my force of gravity, which is 980 as I calculated. And so therefore my normal force also has to be the same. And then now I just need to calculate my friction force. And my friction force, it is denoted by mu Fn. And inputting the values, I get a friction force of 686 newtons. So now I know that Fnet is equal to ma, and my Fnet in this case is only Ff because that's the only horizontal force. So therefore I plug it all into this equation, where this was my Fnet, this is my m, and this is my a, and I found that a is equal to 6.86 meters per second squared. Okay, right here. So now I look at my kinematic equation, see what includes my time, my final velocity, my initial velocity, as well as acceleration. And I found that this equation fit the bill. Plug everything in, right? And then solving, I get 3.9 seconds using my proper significant digits. Hey guys, so here's the second question here. So it says a 200-gram box is placed on a 20-degree incline and accelerates at 0.1 meters per second squared. What's the coefficient of friction within the box and the incline? So let's just draw a quick picture to see what's going on there. Alright, so the right angle, 20 degrees incline of a box. It is sliding down. The acceleration is 0.1 meters per second squared. Alright, so what are my givens? My mass is 0.2 kilograms. Always got to use kilograms. My acceleration is 0.1 meters per second squared. And I know that I have an incline of 20 degrees. Okay, so that's that. So, what do we always start with? Free body diagram. Yeah. Going down. Fg, what is it equal to? Well, mass times gravity, 0.2 kg multiplied by 9.8 meters per second squared. So doing that calculation, I got 0.2 times 9.8, 1.96 newtons. Okay, so now the normal force isn't pointing upwards anymore, right? It's actually going to be at an incline of 20 degrees from the vertical, okay? And that Fn corresponds to this component of the Fg, where this is also 20 degrees. So now we're tilting the bad boy, because it looks like most of sorry, I shouldn't have drew that angle, because you can see that, like, as eventually as we do this, it's going to be this component of Fg that's going to be our net force, right? So let's just tilt this diagram so it's easier to look at. So now Fn is going to be pointing straight up. My Fg, it's going to be pointing at an angle. Okay. Where my Fg, it's 1.96 newtons still. So the vector never changes, it's just the components that change direction. So this is going to be the component that's the same as my normal force, and that's going to be the component that's the same as this net force here. I'll call that F net. So it's not an applied force because it's just the horizontal component of Fg. So a better way to call it would probably be, you know, Fgx, where this is Fgy. Okay. So what's Fgy? Fgy is equal to, so you see my triangle here, it's opposite over hypotenuse. So just quickly, it's going to be 0.96 newtons multiplied by sine 20. And if you want to check this, like you see how I kind of just skipped steps and just went straight into this equation. You know that sine 20 is equal to the opposite over hypotenuse, where my oh no, I made a mistake there. That's supposed to be cosine. Oopsies, sorry about that. Cosine is supposed to be equal to adjacent over hypotenuse. So my adjacent is Fgy in this case, and my opposite is Fg. So I just move my Fg over there, so I get Fgy is equal to Fg cos 20. I plug in 1.96 for Fg, and I get this equation there. Okay, so let's just get that out of there, make it a little cleaner. So now calculating this in the calculator, 20 cos multiplied by 1.96, I got 1.84. 84 newtons. And now that is also equal to my normal force. Okay, that's my normal force. Oh man, I totally forgot that we gotta have a friction force here too. Sorry, my mistake. So therefore, Fnet is not equal to Fgx. That is just Fgx. Yes. Sorry, I'm making tons of mistakes today, guys. That is my bad. So I'm just going to draw this FF a little bit smaller so it kind of represents the magnitudes here, like that. So you can see that my Fnet is actually going to be a combination of Fgx and FF. I'll make that there just because I kind of forgot, sorry. Okay, so where was I? So now we have our normal force, therefore we can calculate our friction force. Well, our friction force is mu Fn, right? So what's my coefficient of friction? Oh, look at that. I don't know, but my normal force is 1.84 newtons, right? So since we don't know what mu is, since that is kind of the question, we gotta start from the acceleration in Fnet and work backwards. Okay, so I'm just gonna give myself a little bit more room here. Oops. No, don't do that. Okay, anyways, we'll just keep that for now. So going down, we know that our acceleration is 0.1 meters per second squared. Therefore, Fnet equals to ma, right? And our Fnet, what is Fnet equal to? It is Fgx subtracted by Ff, right? So it's 0.1 kilograms, 0.1 meters per second squared. Sorry, I kind of forgot to calculate Fgx, so let's do that now. Fgx is equal to 0.96 newtons multiplied by sine 20, which is equal to multiplied by 1.96 is 0.67. So plugging everything in, 0.67 newtons minus Ff is equal to 0.01 1 newtons. Okay, so 0. Okay, you know what? I'm just gonna check that calculation. I don't even trust myself. 0.1 multiplied by 0.1. Yeah, I was right. 0.01. Okay, so now I'm gonna move FF over to this side to make it positive. Move 0.01 over this side to make it negative. So therefore, FF in the end becomes 0.67 minus 0.01. 0.66 newtons. Okay, so my friction force is 0.66 newtons. So taking this and plugging it back in to this bad boy here, I get 0.66 newtons is equal to mu 1.84. So this is the static. No, sorry, not static friction. This is dynamic friction. So mu d is equal to 0.66 divided by 1.84. So it becomes 0.36. And voila! Did I get the right answer? 0.35. Ah, close enough. Close enough. Alright, so here we have your first pulley question. Okay, so hopefully this stuff isn't too new for you. You guys covered in grade 11. So you just gotta remember that every point in a certain rope, no matter if it's before or after the pulley, it always has the same tension. This question is not too bad, so I'll show you how to do it. So the tension in both ropes is 2850 newtons. What is the acceleration of the 325 kilogram mass at the moment pictured in the diagram? Okay, so first things first, free body diagram. We have Fg pointing downwards, and that is equal to 325 kg multiplied by 9.8. Alrighty, 325 times 9.8, 3185. 185 newtons. Okay, and finally we have two tension forces. Ft, we'll call this Ft1, we'll call this Ft2, but they're both of the same magnitude of 2850 newtons. 2850 newtons. Is there a normal force in the case? No, because there is no ground or anything that's holding the mass up. It's actually the pulleys that are actually holding it up. Okay, so how are we going to solve this question? It's asking for acceleration, so at that moment you should realize that you're kind of looking for the F net, okay? Because you know that F net is equal to ma, where this acceleration is what you were trying to find, okay? So first of all, I hope you guys notice that the F net in the x direction is 0, because these two ropes are pulling at the exact same angle. Therefore, their x components pulling this way and this way cancel out. Okay, so it doesn't actually move left to right. So therefore, the only direction for it to move is up. Okay, so our F net, you should notice that it's going to be pointing upwards here. Okay, so I'm just going to draw a dashed line there and here. So you know that those are both right angles. Since this line here is 62 degrees, this angle here is going to be 90 minus 62. And I mean, you could have used like 62 to do your SOHCAHTOA or whatnot, as in using this triangle, but I didn't want to use this triangle just because it kind of interferes with my label, or I'm just lazy. But anyways, we'll use this here, 28 degrees. So now I'm looking for the adjacent side, which is this side here. Okay, so Ft1 is equal to Ft1y is equal to Ft1 multiplied by cos of 28. And this is also going to be equal to the Ft2y as well, just because you can tell, like, you know, they have both the same magnitude and the same direction, therefore they're both going to be the exact same magnitude as well. Okay, so doing this in the calculator, we have 2850 newtons multiplied by cos 28, and it's equal to multiplied by 2850 equals to F25, what was it? 16. And I'll just leave it at that significant digit for now. Okay, so now we're still not done yet. So all we found was the FT1, FT2Y, which is both like that, and we know that F net in the Y direction, it's going to be equal to, so if I set my diagram as that is positive, we have FT1 plus FT2 minus FG. So that is equal to MA, where FT1 is 526 newtons. We'll just multiply that by 2 to take care of both of those, and then I'm going to subtract my FG, which is 3185 newtons. So subbing in my mass, it was 325 kilograms multiplied by acceleration. Just doing this calculation here. We have 2 times 2516 equals to that, minus 3185 equals to that. So 1847 newtons. So finally my acceleration, dividing both sides by 325, I get 5.7. We'll actually do significant digits. I was given how many? I was given 3, so I gotta go up to 3 significant digits. So 5.68. I'm gonna use that. 5.68 meters per second squared in the up direction. And that is my answer, which matches up with the answer here. Alright guys, so here's the first serious pulley question, okay? So I hope you guys know that pulleys, their job, it is just to redirect the tension force, okay? It redirects the tension force. It doesn't change anything if it's frictionless. It doesn't change how much tension's being on the rope. So no matter what point you're on the rope, it always pulls the same direction. So this force pulling on the 4 kilogram weight is the exact same as the tension pulling that weight up. Okay, so let's start this question. So find the acceleration of the 4 kilogram mass. So the acceleration of the 4 kilogram mass is exactly the same as the acceleration of the 2 kilogram mass, except they're both going at different directions. Where the 2 kilogram mass is going upwards, 4 kilogram mass is going to be going, not upwards, this way. So it's either going up the hill or down the hill, and this one's going to go up the hill or down the hill. So they're different directions, but they're the exact same acceleration, just because they're tied with a rope. So they're one system that moves together. So how do we start this question? We just use free body diagrams first. So that's my first one for the 2 kilogram weight. So we have our force of gravity, we have our normal force here, where this is 50 degrees on the vertical, and then we have our tension force pulling up, Ft. Okay, and hopefully you guys can see that these are perpendicular, because the normal force is always perpendicular to the direction of the slope, and the direction of the slope is actually where the tension force is also pulling. So you just draw it like that. For the 4 kilogram weight, we have our force of gravity, we have our normal force pointing this way, where that again it is 30 degrees, and our tension force is pulling this way. Okay, so now since they're both different free body diagrams, I can rotate them independent of each other. So I'm just going to rotate it so it's easier to see. Okay, so that's going to be my new normal force. This way is going to be my tension force, and angle downward is going to be my gravity force. All right, and this one I'm going to rotate it so normal force is up, tension force is pointing this way, and gravity, well, not downwards, it's pointing this way. Okay, so hopefully you guys see that rotation, where this is still 30 degrees and this is still 50 degrees. Okay, alright, so now we're interested in acceleration. Since we already know that the ramp is going to fully support the weight, and it's not going to accelerate through the ramp, you can kind of just ignore the F net in the y direction in both free body diagram, because you know that this force is going to be, counterbalanced by that force, and this normal force is going to be counterbalanced by this gravity force. So it's not really a big deal for us to take a look at that. So what we actually do need to look at is the horizontal. Okay, so we're trying to find the net force in the horizontal for both free body diagrams. Okay, so how are we going to do this? So first of all, the only other component here is FGX here and FGX here. So you should probably come up with a better naming convention. So I'm just going to label this as the 2 kilogram weight. I'm going to label this as 4. So I'm going to use a subscript 2, FGX2 and FGX4. So what's FGX2 equal to? It is, let's see here, sine 50 multiplied by Fg, which is going to be the mass, which is 2 kilograms, multiplied by 9.8. Hopefully I didn't lose you there. So we just have the force of gravity multiplied by sine 50, and FGX4, which is going to be sine 30 multiplied by 4 kilograms, that's an ugly ass 4, 9.8 meters per second squared. Alright, so now let's calculate them both. So I have 50 sine multiplied by 2 multiplied by 9.8. I got 15.01 newtons. And then here I get 30 sine multiplied by 4 multiplied by 9.8 equals to 19.6 newtons. So now, what's my F net in the x direction for this diagram for the 2 kilogram? F net in the x for the 2 is equal to, let's see here, we have Ft, which is going to positive, minus Fgx2. Oh, I forgot to do the sign convention, sorry. Okay, so now we have 2 kilograms, so I'm just going to sub in MA on this side. 2 kilograms multiplied by A is equal to Ft minus 15 newtons. I'm just going to round to 15 newtons. And then here we have F net X 4 kilogram is going to be equal to the force of gravity, which is 19.6. Oh, sorry, I won't skip a step here. FGX4 minus FT. So see how the signs changed just because we're working with the same sign convention but on a different free body diagram. So this becomes negative. This is positive, where on this side this is negative, this is positive. So here we have 4 kilograms, so I'm substituting MA here as well. MA. FGX4 is 19.6 newtons minus FT. Whoa, we look at that. I have one equation, 2 variables, another equation with 2 variables. So I just plug and solve. Okay, so let's do it. Here I'm gonna isolate for Ft. So Ft is equal to 2 kilograms multiplied by A plus 15 newtons. Okay, so that's equation 1. I'm gonna sub it into equation 2. So subbing equation 1 into equation 2. So that's Ft, so I'm actually subbing into that variable there. So I have 4 kg A is equal to 19.6 minus, so I'll open a big bracket here, so 2 kg A plus 15. Alright, so now drop in the brackets here. So I'm just going to continue on over here. We'll have some more space. 4 kg multiplied by A is equal to 19.6 minus 2 kg A. Sorry, I did terrible brackets there. Take that out. Plus 15. No, minus 15. Minus 15. Because we got to expand that negative to both terms, okay? Don't forget that, or else you lose marks. So then now, We got 4 kg. You know, I'm just gonna drop the units here to make it look a little bit prettier. Okay, so yeah, I think this will make more sense to you guys, anyways. So I'm gonna drop the kg, so it just looks like this. I mean, it's not proper in a sense that you're not showing all your units, but I think in this case, doing algebra, I think I'm not going to take off marks if you guys drop the units at this point, just so you can solve it better. So now I just move this 2a over to this side, and I combine 19.6 with 15. So moving this 2a to the other side, I get 6a is equal to 19.6 minus 15 is going to be 4.6. I'm just going to check that just in case I don't trust myself. 19.6 minus 15. Yeah, I'm right, 4.6. So A is equal to 4.6 divided by 6. So I get 0.77, okay, meters per second squared. So that is the answer there. But what am I missing? I'm missing a direction, right? But what is the direction? The direction is just going down the 30 degree slope. So your answer is just good down 30-degree slope. Alright, so you also know that it's going down the 30-degree slope because A, it's positive, is not negative, and it's in the x direction when we rotated this over. So it's actually traveling this way in a sense because we made our sign convention positive, so therefore if my A points this way, then it's going down the slope. So if we re-rotate it back to our old diagram, the acceleration is actually going in that direction. So it's actually going down the slope. Okay. So that would mean the 2 kilogram is actually moving up the slope, and our 4 kilogram is moving down the slope. So if I ask you for this, you just say the 2 kilogram is going up the 50-degree slope. So hopefully that wasn't too hard. Yeah. Alright, so this is the last question, just really quickly. Let's see if I can do this. So 7 kilometer mass, 1 kilometer mass, and this one's free falling, like hanging off the side. This one obviously is sliding on the slope, where the mu k, it's going to be, has a frictional coefficient of 0.4, and k, kinetic force, meaning like when it's moving. Okay, so let's just draw our free body diagram. It's for 1 kg, really simple. Fg of mass 1, it is actually equal to 9.8 newtons because it's 1 kilogram. And we have a tension force which we do not know. And finally we have our 7 kilogram, which is going to be a little bit more complicated, going down. We have Fg is 7, it's going to be equal to 7 kilograms multiplied by 9.8, which is equal to 7 times 9.8, 68.6 newtons. And our normal force is pointing upwards, like so. I'm going to denote this with all the subscript 7. I'm going to catch myself to do these solutions a little bit better. I'm going to even do my sign convention right now, so don't forget. Tension force pulls this way. And notice how I don't put a subscript on the tension forces. That's because the tension force is always the same. This has the same magnitude as this, okay? Never forget that. Okay, so now let's rotate this so it's easier to see. So up, it's going to be my normal force, and at an angle, it's going to be my gravity force, and forward, it's going to be my tension force. Oh, what force did I forget? I forgot friction force. F. Okay, so therefore F of the block of 7 kilograms. Okay, so we actually have 4 forces pointing in different directions. Okay, so redraw on this. This has an angle of 30 degrees over here. So let's just do Fnet calculations now, okay? So in this case, the Fnet is in the y direction. Fnet y is equal to Ft minus 9.8. I'm just going to draw, okay, so in this case for pulleys, like I said in the question before, you don't have to worry about units once you get into these ugly equations. So this is going to be summing in for MA, it's equal to Ft minus 9.8, So what's my mass? My mass is 1. 1 multiplied by A is still A, so I'm just going to write A is equal to Ft minus 9.8. In this case, once again, you'll know that the normal force is going to balance out the y component of the gravity force. So we got to find that. So what's the importance of this? Usually the first question I ignored it, right? That's because we didn't have a friction force. In this case, we do have a friction force. So I need my normal force in order to calculate my friction force. But in order to find my normal force, I need to find the y component of the gravity force. That was a lot to say in one sentence. So FGY7 is equal to the normal force of 7. That's a really ugly equal sign. And that is going to be equal to cos of 30 multiplied by the gravity force, which is 68.6 newtons. So calculate now, cos 30 multiplied by 68.6 equals to 59.4 newtons. Perfect. Okay. So now what is my friction force? Friction force is always equal to the coefficient multiplied by the normal force. Okay. And my coefficient in this case is 0.4 multiplied by 59.4 newtons. Okay. So that is going to be equal to, multiplied by 0.4, 23.8 newtons. So now I worry about my F net in the x direction. So F net y is 0 because it's not going to move through the slope. So F net x for block number 7, it's going to be equal to my friction force subtracted by my tension force. Okay, you can see that it's my friction force in the positive, tension force in the negative. Don't have any other force in the x direction. So places with MA is equal to 23.8. I'm going to drop the units at this point, minus FT. So this is the mass is 7, so I'm gonna sub that in now, and that's it. Okay, so I have one equation, two equations. Okay, so what am I trying to find? I mean, you could find both A and FT. So if I ask you what the tension force, you should be able to calculate it. But in this case, they only find acceleration, so I'm gonna sub in for tension force instead. So isolating for tension, it's gonna be A minus 9. A plus 9.8. So this is going to be my equation 1 actually. So I'm going to sub in 1 into 2. So Ft into that Ft. So I'm going to get 7A is equal to 23.8 minus open bracket A plus 9.8 close. So I just drop the brackets at this point. Whoa, that negative sign applies to both. I make that mistake as well. Minus 9.8. So I'll move that A to the other side, so it becomes 8A is equal to 23.8 minus 9.8. So 23.8 minus 9.8 is equal to 14. So therefore my acceleration is 14 divided by 8, which is 1.75 meters per second squared. And that acceleration, okay, applies to both masses, okay? But what direction? What direction? In this case, this is positive, right? If that's positive, we're subbing this in as positive being the up direction and the right direction. In this case, that would move up. That's my acceleration vector. And this would actually move in this positive direction. But because I was tilted, when I untilt it, it actually moves in this direction. Sorry, I'll use a different color to make it more clear. This direction, right there, okay? That's my acceleration, and up is my acceleration here, okay? So this whole thing is going to move like that, alright? It's going to move like that. And yeah, that concludes the homework.